Hello friends, I welcome you all for the next class, that is for the unit analytic function. And under that, I am going to take you harmonic functions and harmonic conjugate. So already in the previous class, I have taken the necessary and sufficient condition for function to be analytic. So in physics, you come across harmonic motions. So I think this string is moving harmonically. It is a harmonic motion. And in math, these are called harmonic functions, where this surface is harmonic and it is not harmonic here. Okay. So it is having many applications in physics and engineering. So I will define now what is harmonic function. So any function u of xy is said to be harmonic if the partial derivatives of u of first order and second order exist, and they must satisfy, u must satisfy this equation, that equation called Laplace equation. Therefore, any function u of xy is said to be harmonic if all the four partial derivatives must exist and satisfying this equation is called as harmonic function here. Okay. So in physics, you come across that as harmonic function in the form of harmonic motion here. And the solution of usually such motions are in the form of sines and cosines, where sines and cosines are harmonic functions. Then we'll have a theorem under the harmonic. If the function fz is analytic in the given region D, then you have to prove that u and v are harmonic here. So consider fz equal to u plus iv, be analytic in the region D. Then all the four partial derivatives exist and CR equations are satisfied by the necessary condition. If it is analytic, CR equations are satisfied. Therefore, dou u by dou x equal to dou v by dou y, and dou u by dou y equal to minus dou v by dou x here. This is 1 and this is 2 by using CR equations. What to do next? Differentiate partially 1 with respect to x, differentiate partially 2 with respect to y, and adding. So if you differentiate this 1 with respect to x, it is dou square u upon dou x square, and differentiate 2 with respect to y means dou square u upon dou y square. This side is what? Dou square u by dou x dou y. This side minus of dou square v by dou y dou x. But these two are equal, so answer is 0. Therefore, dou square u upon dou x square plus dou square u upon dou y square is 0 means uxx plus uyy is 0 means this u is satisfying Laplace equation and partial derivatives exist, so you can say u is harmonic. Similarly, v is harmonic. Similarly, what to do? You make reverse. You take dou v by dou y is dou u by dou x, and dou v by dou x is minus dou u by dou y, and differentiate this partially with respect to y and this partially with respect to x, and adding, you are getting this equation. Dou square v by dou x square plus dou square v by dou y square equal to 0. That is del square v is 0 here. Same, just to make this is equal to this and this is equal to minus of this. So differentiate this partially with respect to y, this partially with respect to x, you are getting this equation. Okay. So from previous 3 as well as 4, you can say that u and v are satisfying Laplace equation here. Hence, these two are harmonic. So in this way, if the function once it is analytic, then both u and v are harmonic here. That is, if the function fz u plus iv is analytic, then u and v are harmonic. Usually this will be asked for the 5 marks many times along with the definition of harmonic function. Then harmonic conjugates. So once u and v are harmonic in the analytic function, then u and v itself are called harmonic conjugates. That is, u is harmonic conjugate of v and v is harmonic conjugate of u here. Okay. And usually for the question, they will give one of them. Either u they will give asked to find v, and v they will give asked to find u here. Therefore, that theory part will be there. Just I will take one example for verification of a harmonic function. So u equal to x square minus y square minus y, you have to prove it is harmonic. So u is this, go for all the four derivatives. Dou u by dou x, 2x, dou square u upon dou x square, just 2, dou u by dou y, minus 2y, minus 1, and dou square u upon dou y square is minus 2 here. So all these four partial derivatives are polynomial functions, so they exist, and clearly dou square u upon dou x square plus dou square upon dou y square is 2 minus 2, that is 0. Therefore, the function is harmonic. If it is asked, it is only for the 2 marks. Then So this is the theory. They will ask this for the 5 marks. If fz equal to u plus iv be analytic function and being u is given, you have to determine its conjugate phi here. You have to find the value of phi if u is given. So what is the procedure? So the procedure is fz equal to u plus iv be given analytic function and u is given here. We have to find its conjugate phi. So now you have to determine phi. So as u is a function of xy, by using your partial differentiation which you studied last year, d phi is dou u by dou x into dx plus dou phi by dou y into dy here. But by using CR equations, dou phi by dou x is minus of dou u by dou y, dou phi by dou y is dou u by dou x here. Okay, using CR equation as the function is analytic. Then this is dv is equal to m dx plus n dy, where m is minus dou u by dou y and n is dou u by dou x. Therefore, automatically dou m by dou y is minus dou square u upon dou y square, dou n by dou x is dou square u upon dou x square. But as u is harmonic, sum of these two is 0 here. Okay, because already you know that u is harmonic function. Therefore, dou square u upon dou y square is minus of dou square u upon dou x square. Okay, but that is nothing but minus of dou square u upon dou y square is dou square u by dou x square. But this is what? This is nothing but dou m by dou y, and this side is dou n by dou x. So these two are equal. Hence, equation 1 is exact. Because already in BSc 2 you studied that if dy is m dx plus n dy, d pi is n dx plus n dy, that equation is exact. Like that, this dv equal to this is exact differential equation. Here afterwards in the example also, anywhere if you come across, you are right directly, it is exact. So by using the solution of exact differential equation, now v is equal to, exact means it should be integrable. Therefore, v is integration of m dx plus terms of n, this not containing x here, into dy. This is the procedure which you studied. So this is equal to phi, which is the conjugate of u. So this is the procedure to determine phi. So I will take examples. Prove that y cube minus 3x square y is harmonic. Determine its conjugate and find f of z. So here y cube minus 3x square y. So you just find ux uy, uxx uyy. So differentiation of u with respect to x, this is 0. This is 6 minus 6xy. Again differentiate minus 6y. With respect to y, 3y square minus 3x square. Again differentiate with respect to y, 6y here. So all these 4 partial derivatives are polynomial functions in x and y. So they exist and continuous and satisfying Laplace equation. uxx plus uyy is minus 6y plus 6y. It is 0. The function is harmonic. So this question, if it is only this much, it is for the 2 marks. Many times for 2 marks also questions are asked. Next, find conjugate. Let us take VB, conjugate of u. So that dv is dou v by dou x into dx plus dou v by dou y into dy here. Therefore, by using CR equations, replace it by in the form of u minus dou u by dou y, and it is dou u by dou x here. Therefore, this is minus of dou u by dou y, 3x square minus 3y square, because dou u by dou y already you got as 3y square minus 3x square. Minus of that becomes 3x square minus 3y square, and this is minus of 6xy. Already you got it here in previous slide. It is there. Dou u by dou x is minus 6xy. Dou u by dou y 3y square minus 3x square. That you have to substitute. And this equation is exact, not necessary to, that is verified. You please write here only which is exact. Hence, integrating, its solution will be v is equal to integration of m dx plus terms of n not containing x. So no terms, it is 0 you are getting into dy. So it is integration will be x cube minus 3y square x, treating y constant here, and this is 0, okay, and plus some constant c. So which is harmonic conjugate of u? This v itself is the harmonic conjugate. Yes, you got, and f of z is equal to u plus iv here. So if it is asked to find just u plus iv, you have to find u plus u we have tried plus I into v have tried. But in terms of z means you have to convert this for the z here. Just I have adjusted I raised to 4 into I cube. So I into IY whole cube. And this minus 1 can be written as IY whole square. Okay, or I into IY hot, right? And here it is IX cube. I minus of I cube I will write. I is I cube minus I can be written as I cube. And I into IY whole square into this X I keep as it is plus I into C. So all these terms are having I common. X cube plus, that is 3x square I into y plus 3I y square into x plus iy whole cube. It is a plus b whole cube formula. So x plus iy whole cube you are getting plus I into c here. Just it is x cube plus 3x square iy means it is a cube plus 3a square b plus 3ab square plus b cube here. So it is x plus iy whole cube plus I into c. So I is taken outside. It is IZ cube plus IC. So you got f set in the form of Z. If it is asked to find f set in the form of Z means you go for these steps. Otherwise, just find f set means you write this much. Okay. Similarly, next example. Same, just it is exchange. In the place of y cube, x cube is there. X square y equal to minus 3xy square is there. Okay, you have to prove it is harmonic. Find its conjugate. So ux is just 3x square minus 3y square and uxx 6x and uy is minus 6xy and uyy minus 6x. So all these are polynomial function, they exist, and 6x minus 6x is 0 here. So the function is harmonic and its conjugate v. So again by using dv, dou v by dou x into dx plus dou v by dou y into dy here. So this is nothing but minus dou u by dou y, and this is nothing but dou u by dou x by using CR equations. So now I will write minus of dou u by dou y as plus 6xy because dou u by dou y is minus is there. Minus of minus becomes plus. And dou u by dou x is 3x square minus 3y square into this dy you write, which is exact differential equation. Therefore, its solution will be given by v equal to, you have to write here, which is exact, you should write. I am not writing here, please write exact. So m dx plus terms of n not containing x means minus 3y square. Only this term you have to write. So this integration is 6x square by 2 into y, and this is minus y cube plus some constant c. So 6 means you have to cancel here 3x square y minus y cube plus c, which is harmonic conjugate of u. So v will be given, v is this much, where u is given, and f z is u plus ib, u is x cube minus 3xy square, and v is 3x square y minus y cube here, plus I into c. So please write all this in the form of x cube, and this can be written as iy whole square, and this can be written as 3x square into iy, and iy cube can be written as plus I into y whole cube. So it is x plus iy whole cube here, and plus I into c. So it is z cube plus ic here. So this is a form of set. So this is totally for the 5 marks. Okay. So, and next examples I will take in the next class. I think this is sufficient. And before going to conclude the lecture, I'll give you one puzzle. So there are the 2 measures with 4 liters and 5 liters and 1 bucket of 7 liters is there. So you have to fill this exactly, okay, which is of 7 liters using these 2. So within how many steps, okay, by using minimum number of the steps, you have to fill this bucket of 7 liters. So what are the minimum number of the steps here? Taking these 2, okay, using this jar and this jar of 4 and 5 liters, you have to fill this 7 liters bucket. Okay, so how many steps are required to fill this bucket? You please answer me and send the answer in the WhatsApp. Okay, so still then, you please be happy at home and safe at home. Thank you.